web vector, like yeah, let's see, we have these elements in the map, right? So if we want to iterate over all the elements with key 3, for that thing we need the iterator of this element and this element, so we can iterate between all the elements between these iterators. So that is what equal range is doing. It is getting us the iterator of this element and element one past this element. Understood?
If we want to iterate over
Like
all
any
the
doubt? Hello? In multi-map, key are sorted or is it position? Like no, key is sorted. Saram, like is your doubt clear? Equal range?
Yes, that doubt is clear.
Okay. So what did we see till now? It was unordered map, ordered map, and multi-map, right? Similarly, we have unordered set, ordered set, and multi-set. What does set stores? Set only stores key value, only an element. It does not store key or key value pair. It only stores key, only one element. So let's see order. In the map, we were storing the key value pair, right? Key and value. In the set, we are just storing an element. And set is like like sort is set. It has only unique elements. And similarly, we have ordered set where the elements are sorted, similar to ordered map, and its time complexity is log n. And we have unordered set where we have unique elements, but they are not sorted, and the time complexity of accessing, updating, inserting, and deleting these 4 operation is O of 1 on average, but in worst case, it is O of n. So the functions for traversing, insertion, deletion is same as map. We can just glance through it quickly. So we are inserting through insert function, iterating like as we did before. Then the find is used to get the iterator, like iterator of this element. If this element is not present in the set, we get the iterator of the last s dot n. That's why, like if we have element, we would get some iterator which is less than s dot n and it is in the set. If we are having the element which is not there in the set, we would get this iterator. So we are just checking. Okay, if it is not equal to this, so it is present. If it is equal to this, the output of find is equal to s dot n means the element is not present in the set. The erase function same as we did before. Also, it is an ordered set. It is sorted. All elements are sorted. So we can use lower bound and upper bound. And the time complexity of lower bound, upper bound is log n, as you might be knowing. Any doubt in ordered set? I can run this. If you want to see the output. So it is 10, 10, 20, 30. But it would be only 10, 20, 30 because it does not store duplicate elements. Right? Then we are finding 20. So 20 is present, so it will be present. 20 is present. We are erasing 10. So 10, 20, 30, we are erasing 10. So it would be 20 and 30. Yeah, 20 and 30. Count of 20, yes, not count. Count, it would be all in an ordered set or unordered set, it would be 0 or 1. If it's present, it would be 1. If it's not present, it's 0. It's present, so it's 1. And the lower bound, upper bound function. Do we have any doubt here? Okay. Similarly, unordered map. I will be sharing this. You can see this. It's almost same, like almost or 99% same. Multi-set we can see multi-map. It allows us to store duplicate elements. And the main thing here is like the same as we discussed in multi-map, erasing the element. There is
काय
two
काय मस्त आहेत.
ways through which we can erase an element. It's through the key and it's through the iterator. If we use the key, it erases all occurrences of that key. And it is important to know this difference. And to erase only one instance of an element, we use find to get the iterator of that element, and then erase only that element which is pointed by that iterator. So here we are only erasing one element, and here we are erasing all elements with all elements which are 20. Understood? Like, do we have any doubt here? I can run this. So we would have 10, 20, 20, 20, and 30. Yeah, 10, 20, 20, and 30. Count 20 is 3. 3. Is it okay? Do we have any doubts up to here? Now we can like start with question solving. If you are also there is a function. Wait, we can see it at the end, like first time. So let's start with question solving. Yeah. So see, we have been given an array, nums array, which is in non-decreasing order. So we need to find the starting and the ending position of the given target value. If target is not found in the array, we need to return -1, -1, and it should run in time complexity of O of log n. So please be interactive and like answer. So what concept would we use here? If you are unclear with the question, I can explain with example. If this is an array, it is sorted in non-decreasing order. So target is 8. We need to find the position of the first where it is 8 and when it is last 8. So first 8 is at index 3. 0, 1, 2, 3. Last it is at index 4. Similarly in 6, we need to find where is the first index of 6 and last index of 6. 6 is absent in this. So we need to print -1, -1. Understood the question? Uh, Understood the question, everybody? So what concept would we be using now here? Like whatever thing we have learned so far, what thing would we will be using here? What would be the intended solution using? IT v dot found 8 lower bound upper bound, something like equal range in multi-set in equal range. Yeah. So for equal range set, right? So that would take around n log in time complexity. So it's not log n. V dot find, yeah, again same thing. We need to insert in a map or inset, uh, which would take n log n time complexity. Lower bound upper bound, yes, correct. So let's see the solution. Like, what would be the lower bound of 8 in this array? Hmm, It's just difficult to like see chats and like, can you please unmute and say like it would be quick to finish this, or else I will just say and you will hear and the lecture will get end. So see like the lower the lower bound would give us the first index, right? If we want the first index, we would get the lower bound. We would use lower bound. Lower bound of 8 would give us this index. But how do we get the index of the last instance of 8? Can anybody tell that?
upper
कंटाळला
bound
थोडं
minus 1.
राहू दे जाम छोटे आहेत.
So we'll found the upper bound of
झाल्यासारखे
upper bound
वाटत
and
पण नाही.
minus 1. Okay, correct.
बस
Also, we could found the lower bound of 8 plus 1, 9 also.
बस बस घे तू
So we would get the
खाल्ले
next element and then we can subtract 1. So yeah, this is it. Lower bound, the target. We find the lower bound of the target, and that is the index. And then target plus 1. Like we can find the lower bound
बस
of
बस
the target plus 1 element also. It would give us the
हा
index 10.
काय
It would point at the element 10, and then we can just subtract 1. So we get the last index of 8. We are subtracting. But tell me the case where the target is absent. What would we be doing? What would lower bound and upper bound be
चोरी
giving
करे
us? The case where the
Iterator
target is
after the last index.
okay.
We could just check the
What is
element
the
at lower bound. If it is not equal to target, target is not there.
not equal to target? It's not perfect. We can do that also. Also, we can check like if the lower bound and upper bound gives us the same index, same iterator. That also says us like the required element was not present. But what you said was also correct. We can do that thing. I did that. Like if I'm getting a left and right is equal, like both are equal, the element is not present. As we did in this example too, uh, lower bound upper, we used 45 case, right? 45 was absent. We got both as 4 index output as 4 for the lower bound and upper bound. So it says like whenever the element is not present, we get same like lower bound and upper bound as same. So yeah, you can say this. So let's get to next question. Like anyone have doubt in this question?
No.
No doubt.
Hmm?
No doubt. No doubt.
Okay. So the second question is we are having two integer arrays, nums1 and nums2. We need to return the intersection of these both arrays, and each element in the result must appear as many times as it shows in both arrays, and we can return the result in any order. So let me explain this question. So we are having nums1, nums2. We need to output the intersection array, like whatever elements are common in both. Also, we need to output as many number, like if 2 is here and it is 2 times in number nums1, also 2 is 2 times in nums2, so we need to output two twos, not 1 2. Understood the question, everybody? Any doubt in question? So we don't need to check like only if it is present or not, like uniquely. As many times it is present in nums1 and nums2, we need to output here like common. Each element in the result must appear as many times as is shown in both arrays. This statement is important. Did you understand the question?
Yeah. Use a hash map to count frequency.
Yeah. Then
Then uh, iterate over the map. Wait, we'll need two maps, right?
yeah, we have multiple approaches for this. You can like tell your approach. We can then optimize it.
So we one map for nums one and one map for nums two, and we'll compare the elements of each map.
Okay.
And the
And
minimum frequency, if elements are equal, minimum frequency add will be
yeah,
used.
perfect. But can you tell the space and time complexity of that solution approach?
Time complexity would be n log n if you use map.
Yeah.
Unordered would be n on average, but
And yeah, one important thing I like to share, like whenever we are having map or set, we should always try to use ordered map because its time complexity may be log n, but it's fixed. In unordered unordered set or unordered map, the worst case can go to O of n. So it's unpredictable. Like if someone gives you a test case where it fails and where it goes O of n, so it's difficult. Like it's non-deterministic. Like we don't know. We are just on faith. Like it would go O for O of one. So instead, we should have a data structure and operations of whom time complexity we know for sure. Like for unordered map, it is O of one average and O of n worst case. But ordered map, it's for sure log of log n, O of log n. So we should use ordered map and ordered set. And we should mention this in any interview or anyone while you selection of ordered set or ordered map. Yeah, continue. What's the space complexity?
often worst case.
It would be O of n plus n, no?
N1 plus N2 is in nums one and nums.
Yeah. Perfect. So we could also like optimize it by using only one map. Let's see. First, we can see the brute force approach. Like we can iterate over the elements in the second array and check like if it is equal, we just push to this and just make it -1, the element in nums2, because we don't want that same element to be counted twice. You can try this. This is brute force approach. Shouldn't be spending much time on this, so you can see this. It's not important too. The map approach, like which you said. So the map approach which you said, we can have this. Okay. Hmm. Let's see this here. Uh, Wait a second. Hmm. So what we can do is like we can insert elements from either num1 or num2 into a map. Wait. Hmm. Yeah. So we can insert the elements of either num1 or num2 to the map. So here we are inserting the elements of num1 into the map. Okay. We got a map, right? So it's 1 comma 2 and it's 2 comma 2. Agree with this? What map would look like if we're inserting the elements of nums1? We are inserting the element 1, it has frequency 2. We are increasing the frequency count here. It is the value in the nums and it is the frequency of that element. So we iterate, we insert 1. So let's see here. We first element it's 1 in frequency 1, then it's 2 frequency 1, then it's again 2. So frequency would increase to 2 and then 1 frequency increases to 2. So this is what our map stores. Then we just iterate over this nums2 and we check if 2 is if this 2 is present in map. If it is present, we add this into the result array and we decrement the frequency of 2 to 1. So here we are checking like if the frequency of so if the frequency of this nums2 first element in the map it is greater than 1, yes, so we push to the result and then we decrement the frequency in the map, so it would become 1. And then we also check like if it is 0 we need to remove this element, otherwise it would be in the map always. uh, you got this point? Hello? Yeah. So we just see like if it is there or not. If it exists in map, we add to the result. So let's see the code. And yeah, the time complexity and the space complexity. What would be here? Can you tell the space complexity here? Time complexity here in this one.
Log n na that one step.
The time complexity log n. What is n?
Size of it. Now, 1 second. Nums2
Let
side.
let's say nums1 is n1 and nums2 is n2 size. Now tell me what is the time complexity?
This step it is n2. Log of n2.
Log of n2. Uh, is this the overall time complexity of this solution?
Uh, mm, n1 plus n2 log of n1 plus n2.
n1 n1 plus n2 log of n1 plus n2. Are you saying this?
Yes.
Okay, let's see from start. We are inserting elements into map n, so it would be log of like n log n1 log n1, right? Agree for this one.
Yes.
Then we are iterating over m elements, so it is n2 times. We are doing some map operation in this, and the size of the map would be log of n1, right? Because map is storing n1
Yes.
elements at worst case. And yeah, this is it. So we add this. So this is our time complexity. n1 plus n2 log of n1. Agree?
Yes.
And what would you select to like here we are having n nums1 in the map. can you justify my selection of nums1 into the map and not nums2?
Uh, num. Wait, you should have selected nums to maybe because it is smaller size.
Yes, perfect. That was a like defect for you all to find. So we should have find this. And also the space complexity would have become less. Space complexity is O of, in the solution which I am showing is uh, O of n1. But practically it would have been better if I'm having O of n2 because nums2 is small. But how do we do in this code? So this is a nice thing. Like, so we are just checking here if it is smaller. So we can just recursively call this one again, this function again. So it will just reverse the nums1 and nums2. You can say this, the implementation. This otherwise you can do if else. If this is small, if this is large, we can do this. And then we can also use the multi-map in this. What are your like thoughts of using multi-map here? Multi-set, sorry.
Why multiset would just complicate things? It's doing the same thing, counting frequency.
Yeah, agreed. But my intention was to have the implementation of multi-set, like familiarize you with multi-set. Can we do it with multi-set? You can see this
Yes,
implement
count
otherwise
we
at the
can
end.
do, right? Count function.
Yeah. Also, we need to erase the element, right, from the set.
Iterator.
In the yeah. So this is something like iterator. Wait, that is official account. Mhm. Also, what if the nums1 and nums2 were sorted?
Two pointers approach, maybe.
You all are familiar with two pointers approach, or only few are like
Not all,
no.
mostly.
No,
Okay,
no.
okay. So let's see the two pointer approach. Let's say we have this nums1, nums2, and they are sorted, and it's 2 comma 2. So what we can do is like we can have a two pointers. Like let's say this is nums1, this is nums2. We have one pointer at the start of the first array, and second pointer at the start of second array. So we can check if the element pointed by this pointer and by this pointer, is it equal? If it is equal, we add to the result. If it is not equal, that means we need to like, if it is 2, and it is greater than this element, so we may find 2 anywhere ahead of 1, right? So we increment this pointer until we find 2. So we increment this pointer. So what would be the case if like let's say this as p1 p2 nums1 of p1 if it is smaller than nums2 of p2. If this is smaller, we increment p1. Else if this had been smaller, we had increment p2. Agreed? So let's say again p1, the element pointed by p1 is smaller, so we increment this. It is equal. So we increment both of these and store this element in the result array. Again we see these are equal, so we increment the pointer, increment both pointers, and then store this. So this is the answer 2 2. Any doubt here in this two pointer approach? So we are simultaneously checking both the arrays, and the time complexity here would be O of n1 plus n2. Since it is already sorted, we are assuming that it is already sorted, and the space complexity is O of 1. Any doubt here into his two-pointer approach? The code we can see here. So it is what I said, like we are iterating until I exceeds its boundary or j exceeds its boundary. I is p1, j is p2, like as we discussed. So if both elements are equal, we push to that answer and increment I and j both. If the nums2 element is smaller, so we increment the j. If nums1 element is smaller, we increment the I, as we have seen. Any doubt in the two-pointer approach? Any doubt? It went like what thing did you not understand? I can repeat the approach. Like it is important and like many questions are asked. Like many uses this approach. It's an important one. Like so, should I explain it again? Hello, explain it again. Okay. So let's see. If we are having one, two, two. What we are having two pointers. Where we are having two pointers? If we didn't have two pointers, if we had not used two pointers approach, it would have taken O of n square, right? That we are at this. We are considering this index. We iterate to this. We check if there is one or not. Then we again increase this and check this. Again at this index, we check this. Is there two or not? If there is two, we add to the answer and make it -1. Again, we move to this. We see 2, we iterate to this from start. If there is a 2, we make it -1 and add to the answer. The time complexity would have been O of n1 into n2, right? To optimize this, what we are using, we are traversing both the arrays together. If you are having 1, 1, 2, 2, and 2, 2, maybe, yeah, 2, 2. So we are having the pointers at the start, and let's say if we are having a 1 here, this element is pointing to 1 and this is pointing to 2. If uh, I'm considering from this num's point of view, he sees that there is a 2 here and he knows that this array is sorted. So 1 should have been before 2 or it is not there, right? So he can't do anything. So he just moves ahead. And this 2 knows like it is 1 and 2 might be ahead because it is sorted. So it would tell him just to increment this pointer. It increments the pointer. Again, it's 1 and this is less than this. So there's a probability that we find 2 ahead, anywhere ahead. So we again increment this pointer. It is equal. So we just add and we increment the both pointers. So it's like it is sorted. So we know that there's a probability we might find the increasing value ahead, anywhere ahead. That's why we are incrementing the arrays. And that selection of increment, like when do we increment? So it's a simple thing, like whenever whatever the iterator was pointing is less than this, we increment it. So the next element would be greater than the current, and it might equal to the nums2 element. uh, yeah Sorting first and using two pointer after would also give, yeah, agreed. But I wanted to introduce this new method, and I said started with the assumption that it is sorted. Yeah, but it would be this much only time complexity. But if it had been sorted one, then two with map, the time complexity would have been like high. So this is a homework question. This is the easier one of the question which we did previously. So here we need not have like given two integer array num1 and num2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. Each element in the result must be unique, which means if there is two two times and here also two times, we only need to have only one times. So it's a easier version of the question which we did. We can also use lower bound and upper bound here. First we need to sort and then try. So I'm having this as a homework. It would be there in your assignment. I need three approaches: lower bound, upper bound, set and map. It is an easier version of this. These two solutions is like it has been given previously. You just need to do some 1-2 line changes. Any doubt in this question? It is a homework question. That's why I'm asking. And you won't find, I guess, lower one, upper one approach on Google too. It's nice to like ask questions now. Okay, so we can get to the third question. Hmm. Hmm. Let's do the fourth question. So given an array of integers nums and an integer k, return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. This question is we will solve this using sliding window, but let's understand the question more clearly. We have been given an array nums, and there is an integer k. We need to find the subarrays whose product is strictly less than k. Let's understand the question. So this is nums, this is nums, this is k. We need to, and what is a subarray? Subarray is a contiguous elements in an array. So let's say we have 10. This product of 10, like 10 with 1 only, it's a 10 is less than k. So that is one of the subarray which we need in the output. Then it's 10 comma 5. What's the product? 50. 50 is less than k. So it is also answer we can include. 50, 10, 5 comma 2. It is 100. It is not less than 100, right? It is equal. So it cannot be in our answer. Then 5. 5 is less than 100. So we can have in the answer. 5 and 2, 10 less than 100. We can have in the answer. 5 to 6, 60. We can have in the answer. Then 2 less than 100. We can have in the answer. 2 comma 6, 12. We can have in the answer because it's less than 100. And then 6. So these all subarrays we can have in the answer. How many are there? Let's count it. 8. And yeah, output is also 8 na, here. These are the subarrays which can have. So what is your approach for this? The n square approach, like the brute force. Did you get the question? Everybody got the
Brute
question?
force would be just to count or enumerate all subarrays and then find their product. That would be n squared.
Yeah, perfect. Uh, so let me like quickly get explain this brute force approach, because after understanding the brute force, like we can optimize it better through using sliding window. So the brute force would be like we are getting this 10, selecting 10, and then we iterate over this array again and multiply this 10 10. Sorry, we cannot have the same element, so we would multiply this. If it is less than this, we would have it, and then we can check with 2. So actually wait, let's get to sliding window. Like I have to finish this lecture. So let's say 10, 5, 2, 6. What we are doing, like we would have a sliding window. We would have a window. The size of window would be variable. We would dynamically increase or decrease based on the conditions. So, and we would slide this window. Currently the window is here. We can slide it here, slide it here. So we can do this. So on what basis would we be sliding the window? So first, we would have 2 pointers which would help us maintain the right end and the left end of the window. So this is right, it is left. So we would get the product. Product would be right element, nums of right. Like whenever we increase the window, we multiply that to the product. So initially we added 10. So product initially is 10. Is it less than this? So let's suppose say if our so there is a one subarray of 10. Then we increase the R. So we now our window is this. So its product is 50, right? 50 is less than 100. So what should we increment? Increment by 1 or how much number? Like if we like with the addition of in this window with the addition of 5 we are getting two subarrays which are having sum less than 100. Do you got that? Like 10 comma 5 is having a product less than 100 and this 5 is also having a product less than 100. So there are two subarrays which are contributing to the answer by the addition of this 5. Got this? So we would just increment the answer by the right, that this is right, this is left. So we know that whatever is the size of this window, that much subarray like are contributing to our answer. So it would be R minus L plus 1. So here it's R0, 1. So 1 minus 0 plus 1, 2. And we are getting 2, like 10 comma 5 and 5. These two subarrays. So we increase the window. We increase the window until our product is less than 100. Again, we increase the window. The product is 100. It is not less than 100. So we decrement our window size. For decrementing the window, we need to increment the L. So this is our window. And while decrementing, we need to divide our product, this product, we need to divide by the element at left and check. So it is 10, right? 10 is less than 100. So we again increment this by R minus L plus 1. Why R minus L plus 1? Because the addition of 2 gave us to two subarrays which are in our answer, like 5 comma 2 and 2. Then again we increment the this window size of we multiply 6 into the product, we get 60. 60 is less than 100. So again we need to increment our counter. So what would be increment our counter here by R minus L plus 1. So it is 3 and it is 1. So 3, increment by 3. And why 3? Because the addition of 6 to this window got us 3 subarrays which would contribute to our answer. Which 3? 5 comma 2 comma 6, 2 comma 6 and 6. Understood why we are taking R minus L plus 1? Any doubt like in this approach? The window sliding. Maybe you can say the algorithm like so. This is the right pointer. So every time we increment the right pointer, okay. Let me like explain this. So every time we increment the right pointer, we multiply it to the product and check like if the product is less than 100, less than k or not. If it is greater than 100, greater than equal to 100, we need to decrease our window size. So we increment the left, and while incrementing the left, we need to divide that element too. Like we need to remove that element from the window, and then we increment the count by right minus left person. So the extension, like everybody got this approach, and the time complexity of this approach would be O of someone can predict what would be the time complexity here. This approach. You can see the code. Don't
Uh,
see this.
mm,
Yeah. O of. So it would be O of 2n because we are it our right pointer it in the worst case our right pointer iterates from 0 to n and a left pointer also iterates from 0 to n. So in the worst case it would be O of 2n like O of n only, but O of 2n. It's same, but then let's see the extension of this problem. In this question, the condition here was like we need to find subarrays whose product is strictly less than k. Whose product is strictly less than k. But now we need to find the subarrays in which the product is exactly equal to k. Can anybody tell how can we do this? Quickly, like it is last question for you today.
strictly less than k, right?
Strictly less than k was the previous question. This question is exactly equal to k.
Oh, sorry. Exactly equal to k. We would start with left and right pointer, then keep adding elements till if it is greater than k, then we remove the left side. If it is equal to k, we simply add that subarray and we forward to the right next increment right. When it goes greater than k, we increment l, and when it's still lesser than or equal to k, we increment right.
When do we increment height?
Whenever the product is lesser than equal to k. If zero is
Product
there, then there might be problems.
product is less than equals to k. And increment left
Greater.
when it is greater than k. Mm, yeah, we can do this. So, but let's see. Mm, yeah, we can try this one also. Like, I would add this in PPT also. Uh, according to me, it will fail. Like, I'm not getting the test case now. So, otherwise, there is also an approach like inclusion exclusion. Like, we can say we already have the code for subarrays less than 100, less than k, right? The previous question.
Yes.
So we can do like if we are having for less than k, then we are having less than k plus 1. we can subtract that and we get the k, right? If we are the code is giving us the subarrays which is less than which has product less than k. So if we get uh, if we calculate the subarrays which are having product less than 101 and subtract it by the product of subarrays which are having product less than 100, we would get exactly 100, right? Like
Yes.
the subarrays which are having product exactly 100. Understood this. Like this is a like because this property is used in many questions and like it is important to know, and it is like if you are seeing this question, if this property you are seeing for the first time in some question, you won't like get from intuition. It must be like you should have been seeing this anywhere before. So this is what it is. The product of all elements in the subarray is exactly equal to k. So this is the solution for it. So we are just this is the same function which we used in the previous question. We are just using calling this thing function of nums with the k parameters k plus 1 and k and subtracting this. Did you got this? You got this thing. The subarrays product less than 101.
Yes.
So this code also like got what we are doing for this problem. This problem. Can you tell like where are you? What like what thing you not understand? We can discuss that.
What?
Did you understand this approach?
Yeah, inclusion, exclusion, understood.
Yeah. So there is one problem. It would be in your assignment too. I have given the code also, but it is having the it is similar to this previous question, fifth question, inclusion exclusion. Because what is the question? We are having nums array and integer k. We need to find the good subarrays of n. What is a good subarray? In which the different elements, unique elements in that subarray is exactly equal to k. So similarly, we can count the good subarrays which are having unique elements less than k. Then we can find more than k, like less than k minus 1, less than k, and subtract both. You got this?
Yes.
The approach is similar to the previous one, but just the edge here is like we need to maintain a map or a set or a multi-map to count like how many unique elements do we have. We have the code. This is your assignment. I want the approach and the explanation from you. That's why I'm providing the code, and like you can just see this, and it is like a bit like category of question. Like you need to see before. You can't solve it on first time. So yeah, that was it. And also there is some in the previous lecture in the binary search we had you had you need to find the maximum element, right? You were required to find maximum element, right? In the binary you are writing some function here integrate max element in the array, right? For maintaining the high pointer, high value.
Yes.
So what we could have done is like there is a max element function in STL int max element equals to max element. We get the iterator. It gets us the iterator. Uh, this max element gets the iterator to the max element, so we need to dereference it. We can see it. So it is like quick, like you can use fast writing fast code. So yeah, max element is 60. So it's, and the array need not be sorted. Similarly, we have min element function, so you can like quickly get the max element and min element. This is also part of the STL. Also, there is next permutation function in STL. So what are permutations? You might be aware, like if this is the given array, how many permutations we can have? Permutations is the element unique, like different
Total
array,
elements factorial over product of like how many times an element
similar.
is repeated factorial.
Yeah, perfect. So here it would be 3 factorial, right? 3 factorial choices. 3 factorial permutations we would get here. 6 permutations.
Yes.
3, 2, 1. So for that, this next there is a function in STL, next permutation. It generates the next lexicographically larger permutation. So it's just a one line of code, and there is a question in lead code. It is a medium like, and to implement this from scratch, it is a like it is a medium level question. So yeah, you can see this. So we are just getting all the permutations by using this next permutation. And I have the link to this question in this. So it is just one line of code. And if you try to implement it without next permutation, it's a bit challenging. You can see. And in C++, for using the STL library, we need to include this header files like algorithm, map, set. But we have that it's class std, so it includes all these header files. So we need not write include all the header file, and just this one header file gets us everything. So yeah. So you have two questions as homework from this PPT. I would add it into the assignment. First is this. Wait. Yeah, this last question. 6. Uh, and this easier version. We need to use all these approaches and get me the answer. I want the explanation for all these approaches. Yeah. So that's it. Like if you have any doubts or anything, we can discuss it now. The usage of set or sorting order or collisions or anything.
So I was asking before, in a hash map, there is something called custom hash. It uses like product of two primes. Isn't that all STL version?
I didn't got your question. Like, can you explain it?
See, I don't know much, but there is something used in hashing, right? Like
Hmm.
cryptography, similar to that.
Hash. Mhm. It
So,
uses a hash
wh-
function. Like there is
so why
some.
do people make custom hash functions? Isn't STL already enough?
I'm not aware of custom hash functions used. Like I haven't seen it. Paras,
Oh,
I think he might have seen.
Am I
Have you
audible?
seen? Yes, yes. Do you want to answer this question?
Yeah, yeah. हा थांब माझं काम आहे. Yeah, so hash function works basically like there is some mathematical operation performed on the number, and based on that, we store that particular number. So, for example, consider modulo operation. In modulo, you take a size of a container, let's say it is 10. So, for each number to be stored in the map, we take the number modulo 10 and store it corresponding to that particular position. But what happens if two numbers have the same modulo? So in that case, collision occurs. So for that, we have different methods. You can read about that, the methods to prevent collisions for hashing. So the custom hash function of the unordered map or unordered set, like the one used in the STL, does not work very well. It has a very high probability of collisions. So if you are solving competitive programming questions, there's a high possibility that you can get a time limit exceeded, even when you are running an order of n solution. So this happens because of the collision and the extra order of n lookup time of that particular container. So whenever you want to check whether a number is present or not, if due to the collision factor, it can go a worst case up to linear time. So the order of n solution could go up to n square, right? So for that, the custom hash is used, which has a better way of handling the collisions. If you want to read the mathematical part, you can read it from the Google, but uh, for your current level, it's not necessary.
Okay, thank you.
You just need to like know like why do collisions happen, and yeah, why the worst case gets to O of n.
Understood.
Like any doubts in today's lecture, any function we can like discuss. If anyone have doubt, others like if those who don't have doubt, they can leave. Wait. Attendance, Paras. Hello,
Taken.
Lilia.
Ah.
Okay, so like those who do not have any doubt, they can leave. If anyone have doubt uh, regarding anything in covered in today's lecture, they can wait.